So in this problem, we are asked to first identify the different number of hydrogen environments and specifically state where they're at. We also need to explain the multiplicity. Can never say that word. We're going to find the multiplicity of those hydrogen environments at each respective signal. So let's get right into it. We have this simple molecule right here, just a simple little ester. So let's see our different hydrogens that we have. So we have 2 here, 2 here, 3 here. We have 3 here. And we have a single hydrogen here. So let's get right into it. How many respective environments do we have? Well, I don't see any symmetry, although I do see some symmetry here due to rotation. This bond can rotate, and if I blindfolded you and I rotated this molecule, you would not be able to distinguish which hydrogens are which. So for that reason, we know that these are chemically equivalent hydrogens. This is its own hydrogen environment. It's not like the other ones. We have a pair here that's equivalent, pair that's equivalent, and we have these 3 that are equivalent. So now that we identified the equivalency, we know that this is going to give to 1, 2, 3, 4, 5 signals respectively. So we'll write 5 signals. But what's the multiplicity of each signal? So multiplicity on an NMR spectra tells us the number of neighboring hydrogens plus 1. So it follows that n+1 rule, right? So for this signal here, how many splits would we be likely to see? Well, we'd see 1 due to this hydrogen neighbor, and we'd see the 1 just because of the n+1 rule. So this would be a doublet. Looking at this hydrogen, to its left it has an oxygen. That's not a hydrogen. And to the right it has 6. So we're going to see, I'll call it a 7-lit or a multiplet, I should say. Geez. So a 7-lit is what we would see, right? The 6 plus 1. Moving on. This signal here, it has 2 hydrogen neighbors. That'd be a triplet. And this one has 2 and 3. That gives us a total of 5 plus 1. That's a 6-lit. And finally, we have this kind of terminal carbon hydrogens, and we see that there's 2 hydrogen neighbors plus 1. That's a triplet as well. So hopefully that makes sense. We'll get onto the other molecule here to save time, because this is timed, guys. This is a timed assignment. Let's label all the hydrogens here. We see that this is a meta-substituted benzene. So let's go ahead and draw in all of our hydrogens real quick. Oh, brother, this is going to be fun. We've got a tert-butyl group. Look at that. I won't bother drawing in all the hydrogens, but all the little branches you see there, those are hydrogens that I'm implying. Well, equivalence-wise, these are all equivalent due to free rotation. These 2 are equivalent. This is, there's no symmetry in this molecule, right? No hydrogen on the benzene that's just a direct connected to the benzene is similar to another one. They're all respective environments. So those are 4 respective environments, and we have the aldehyde hydrogen there. That itself is its own respective environment. So let's go over the number of signals. It'd be 1, 2, 3, 4, 5, 6, 7. So 7 total signals. 7 signals. And what would be the multiplicity of all these? Well, let's start with our tert-butyl. Well, there's no neighbor. Now, don't get confused with this. These 2 hydrogens here. It has no neighbor, right? That central carbon is like kind of blocking it from having a neighbor, right? So this would be a singlet here. Because remember, even though we have 0 neighboring hydrogens, n+1 tells us that there will still be a peak there. This one here, same diff. It's also going to be a singlet because there's no neighboring hydrogens. This one here has a one neighbor, so this is a doublet. This has 2 neighbors, so that's a triplet. This has 1 neighbor, so this is a doublet. And this has no neighbors, so this itself is also a singlet. A lot of singlets here. And we can also say the same of this here. This is also a singlet because it has no neighbors, n+1. So hopefully that helps understand, and you can see this here. Hope you guys enjoyed. I have a couple more practice problems in relation to this homework assignment. Same kind of thing with NMR and writing that out. So have a wonderful day.